Hello everyone. Today we will apply together to chapter 5, data handling. Today's lesson consists of 5 parts. The first part is looking for information. The second part is organizing data. The next, grouping data. The fourth part is psychograph or pie chart. And then the final part, chance and probability. We get to the first part, looking for information. A pictograph, representation, numerical data by using picture or symbol is called a pictograph. Pictographs are easy to read, express large number of data, but cannot express exact value. Example 1. Below is a table showing the number of cars produced in 3 months, July, August, and September. Look at the table. One symbol stands for 100 cars. How many cars were produced in the month of July? Look at the table. Look at the table. There were 100. Look at the table. There were 250 cars produced in July. Because one symbol plus one symbol plus half part of one symbol equal 100 plus 100 plus 50 equal 250 cars. In which month was maximum number of cars produced? September was maximum number of cars produced because it had 400 cars produced. B. A bar graph. A display of information using bars of uniform width, their height being proportional to the respective value. Bar height given the quantity for each category. Bar are of equal width with equal gap in between. The information given by the bar graph is number of students in class 8, 20,004 to 20,005, increase 100 students. Every year, since 100,005 to 100,006, 100,006 to 100,007, 100,007 to 100,008. Every year we have 50 increased students. (100,004 to 100,005) were increased maximum. 100,007 to 100,008 was the number of students maximum. The number of students during 100,004 to 100,005 is twice that of 100,003 to 100,004. C. A double bar graph. A bar graph showing two sets data simultaneously is useful for the comparison of the data. The performer improves the most in math. The performer deteriorates in English. The performer apart in Hindi. 2. Organizing data. Usually, data available to us is in an unorganized form called raw data. To draw meaningful inference, we need to organize the data systematically. For example, a group of students were asked for their favorite subject. The results were as listed below. The table consists of 3 columns. The first column is the name of the favorite subject. The second is tally marks, and the first is number of students. Asked 1, 2, 3, 4, 5, 6, 7. 7. Mathematics 1, 2, 3, 4, 5. 5. Psych 1, 2, 3, 4, 5, 6. English 1, 2, 3, 4, 4. The number of tally before each subject gives the number of students who like that particular subject. This is known as the frequency of the subject. Frequency gives the number of times that a particular entry occurs. Frequency distribution table gives the number of times an entry occurs. 3. Grouping data. The data regarding choice of subjects shows the occurrence of each of the entries several times. This information can be displayed graphically using two pictographs or a bar graph. Sometimes, however, we have to deal with a lot of data. For example, consider the following marks out of 50 obtained in mathematics by 60 students of class 8. If we make a frequency distribution table for each observation, then the table would be too long. So for convenience, we make group of observations, say 0 to 10, 10 to 20, and so on. The obtain of frequency distribution of the number of observations falling in each group. Thus, the frequency distribution table for the above data can be 0 to 10, 2, 10 to 20, 10, 20 to 30, 21, 30 is 40, 19, 14 is 50, 7 and 50 is 60, 1. Total 2 plus 10 plus 21 plus 19 plus 7 plus 1 equal 60. Data presented is a manner is that to be grouped, and the distribution obtained equals the group frequency distribution. It helps us to draw meaningful inference lines. Thus, most of the students have scored between 20 and 40. 2. 8 students have scored more than 40 marks of the 50 and so on. Each of the groups are 0 to 10, 10 to 20, 20 to 30 is called a class interval or purify a class. In the class interval 10 to 20, 10 is called the lower class limit and 20 is called the upper class limit. This difference between the upper class limit and lower class limit is called the width or size of the class interval. Grouped data can be presented using histogram. Histogram is a type of bar diagram where the class intervals are shown on the horizontal axis. The height of the bar shows the frequency of the class interval. Also, there is no gap between the bar as there is no gap between the class interval. For cycle graph or pie charts. Today, she had collected jasmine, marigold, and rose flower. Their number are as follows. Let's represent this information in an interesting way. The total number of flowers here is 30 plus 20 plus 10, which is equal to 60. Here's the number of jasmine flower is 30, which is 30 by 60, that is half part of the total number. Similarly, the number of marigold flower is 20 by 60, part of the total number. That is 1 by 3, but the number of rose flower is 10 by 60, that is 1 by 6, part of the total number. We would consider the value of an entire cycle to be 60 flowers since the central angle of an entire cycle is 3600 degrees. We can say that 60 flowers represent the central angle of 3600 degrees. The number of jasmine flower in 1 by 2, part of the total 60 flower. We will represent this number from a sector of a cycle whose central angle is 1 by 2 multiplied by 3600 degrees, which is equal to 1800 degrees. That is half cycle. Similarly, the portion of marigold flower can be represented by making the sector with central angle of 1 by 3 multiplied by 600 degrees, which is equal to 1200 degrees. And the portion of rose flower with a central angle of 1 by 6 multiplied by 3600 degrees is equal to 60 degrees. Here we have represented from of various sectors of the cycle a presentation in which the data is represented by the sector of the cycle is called a pie chart. A pie chart tells us the relation of the whole to its part. For example, for 30 jasmine flower, the total number of flowers is 1 by 2, part of the total 60 flowers. Likewise, for 10 row the total number of flower is 1 by 6 parts of the total number, and 20 flower of marigold is 1 by 3 of total number flower. At the same time, the pie chart also helps us to compare in different parts. For example, it can be said that the number of marigold flower is double and the number of jasmine flower is triple as compared to the number of rose flower. Pie chart. Jasmine 1 by 2 multiply 100% equal 50%. Rose 1 by 6 multiply 100% equal 16 pound 67%. Marigold 1 by 3 multiply 100% equal 33 pounds 33%. Drawing pie chart. Example: the favorite flavors are of ice cream for students of a school is given in percentage as follows. Chocolate is 50%, vanilla is 25%, other flavor 25%. A total angle at the center of a circle is 36,000 degrees. The center angle of the sector will be a fraction of 36,000 degrees. We make a table to find the center angle of the sector. Chocolate in fraction 50 by 100 equal 1 by 2. 1 by 2 of 3600 degree equal 1800 degree. Vanilla 25 by 100 equal 1 by 4. 1 by 4 of 3600 degree equal 90 degree. Outer flavor 25 by 100 equal 1 by 4. 1 by 4 of 36 100 degree equals 90 degree. 1. Draw a circle with any convenient radius, mark its center or and a radius OA. 2. The angle of the sector for chocolate is 1800 degree. Use the protractor to draw AOP equal 1800 degree. 3. Continue making the remaining sector. 5. Change and probability, change and probability some of the word we use daily in our life. We say there is no chance of raining today. We are just predicting there is no chance of raining today. Another one is quite probable that India will win the World Cup. Suppose we have the following statement. 1. Sunrise from the west. 2. Ganga is a river in India. 3. India will the test match. So of the statement, what we can say the statement 1 is always false because sunrise from the east. Second statement is always true because Ganga is a river in India. Statement 3 is not always true or false. India can win the match or not. Both are possible. In statement 3, we can try to find the chance where India can win. Chance is the possibility of something happening. The chance of happening of an event may be described as one of the following. The next independence day will be on 15 August, as we know Independence Day is on 15 August. We call this essential to happen different event. Another example, you see. Tomorrow will be a cloudy day. It may be or may not be, so it can happen but not essential. Another example. Another die when toasted, so land up with egg on top. A die is 6-sided fry, egg on top is not at all possible, so we call this impossible event. So I repeat, chance is nothing but the possibility of something be happening. Another example, you see, if you throw a coin, can you always correctly predict what you will get? It difficult to predict. You see two friends are tossing coin 15 times, Susila and Sama. So they are tossing 15 times a coin, and let us represent a hat for head and T for tail, and we prepare a table. You see number and outcome 15 times 1 to 15. Yes, so first they may be right head or tail. Let's see. First outcome head, next second tail is tail. Third tail is front. Fourth tail is head. Fifth tail is tail. So like that we cannot predict. It may be head or it may be tail. So similarly, I win why on the thing you see. There are the 15 outcomes. Okay, so in this outcome, we do not see any border pattern. We do not get. Here, we see that total number of heads equals 8 and total number of tails equals 7. What is probability? Probability is the start of chance of an event happening. The probability of an event is a number indicating how likely that events will occur. This number is always between 0 and 1, where 0 indicates impossibility and 1 indicates certainty. The probability of events equal number of outcomes that make an event by total number of outcomes of the experiment. Consider few examples. A. We know that when a coin is thrown, it has two possible outcomes, heads or tails. Total outcome equal 2 heads or tails. Probability of getting heads equal number of outcomes that make an heads by total outcome equal 1 by 2. And probability of getting tail equal number of outcomes that make an tail by total outcome equal 1 by 2. In this case, probability of getting hurt equal probability of getting tail equal 1 by 2. Example B. A die is rolled 1. Find the probability of getting even number. Solution. When a die is rolled 1, the outcomes are 1, 2, 3, 4, 5, and 6. Total outcome equals 6. Even number are 2, 4, and 6. Total equal par. 3. Probability of getting even number equal number of ways the even number can occur by total outcome. Probability of getting even number equal 3 by 6 is 1 by 2. C. A box contains 15 red balls and 9 white balls. Find the probability of getting red balls. Solution. Box contains 15 red balls and 9 white balls. Total outcome equal 15 plus 9 equal 24. Probability of getting red ball equal number of ways the red ball can occur by total outcome equal 15 by 24. Probability of getting red ball equal 5 by 8. What have we discussed? 1. Data mostly available to us in an unorganized form is called raw data. 2. Frequency gives the number of times that a particular entry occurs. 3. Grouped data can be presented using histogram. Histogram is a type of bar diagram where the class intervals are shown on the horizontal axis. The height of the bar shows the frequency of the class interval. Also, there is no gap between the bar axis of there is not gap between the class interval. 4. Data can also be presented using cyclograph or pie charts. a psychograph shows the relationship between a whole and its parts. 5. There are certain experiments whose outcomes have an equal chain of occurring. 6. A random experiment is one whose outcome cannot be predicted exactly in advance. 7. Outcomes of an experiment are equally likely if each has the same chain of occurring. 8. One or more outcomes of an experiment make an inference. 9. Chain and probability are related to real life. 10. The probability of inference equal number of outcomes that make an inference by total number of outcomes of the experiment. Thanks for listening.